Okay, some more Chapter 3 review, and this is one that will really test your mettle. This is the second derivative. We want to find the second derivative. Number 39, it says find d squared y dx squared by implicit differentiation. And these are none too easy to begin with, so we've got this. This is my function. I want to find the second derivative, so first of all, I've got to find the first derivative. So we'll take the derivative implicitly. That's going to be 3 times x squared dx dx plus 3 times y squared dy dx. And I'll subtract the 3ax squared from both sides, negative 3x squared, pardon me. I'll subtract 3x squared from both sides. And I'll divide both sides by 3y. And I get dy dx equals negative 3x squared divided by 3y squared. And our 3's cancel, so this is what we have. So that's our first derivative. So now we have to take the second derivative, and that will be the derivative of the first derivative. And we're going to have to use the quotient rule, and we're going to have to do it implicitly, to boot. So I'll put this negative sign in front of the whole thing and see how it works out. And we've got low d high, less high d low, denominator squared below. Low d high, which is low, which is y squared. Low d high, the derivative of the top, is 2x dx dx. Less high, which is x squared, times the derivative of the bottom, which is 2y dy dx, so don't forget that. And the denominator squared below, which is y squared squared, which is y to the fourth. Now we can't do much with this, but we know right over here what dy dx is. It's negative x squared over y squared, so I'll put that in. So this negative x squared over y squared is dy dx. Because like I said, I can't do much with that. Now I have a complex fraction. I just have one fraction in the top, but I can get rid of all that by multiplying the top and the bottom by the LCD, which is just that y squared, so I multiply the top and the bottom by the y squared. Now I've got to multiply both terms. So when I multiply y squared times this term, I get 2xy to the fourth. Okay. And when I multiply y squared times this, the y squareds cancel. So I've got x squared times x squared is x to the fourth. I've got a y, I've got a 2, and a negative times a negative changes that to a positive. So that's looking a little bit better. And what I notice that I've got y here I can factor out and I can eventually simplify. So I factored a y out of both these terms. So that gives me 2xy to the third, 2x to the fourth, a y in front, and then y over y to the sixth. One of these become 1, one of these cancel out to form a 1, and I have y to the fifth on the bottom, and then just this on the top with a negative in front. But now I also notice I have a common factor of x here, so if I factor that x and 2 out, 2x, what's left in the first term? Y cubed plus, if I take the 2 out and an x, 2x, x cubed, pardon me, y cubed plus x cubed, all over y to the fifth. You might say, well, why should you do that? Well, it's not a bad idea to have in factored form, first of all. Okay? And second of all, what's this the same thing as? We go all the way back to the top. Remember, right? As Mr. Spock said to Dr. McCoy at the end of Star Trek The Wrath of Khan, remember, 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 remember. That x cubed plus y cubed equals 1. So this is what we got over here, don't we? X cubed plus y cubed equals 1. So instead of writing this x cubed plus y cubed, I can write 1. And 1 times 2x is just 2x, so I've got 2x over y to the fifth. So that simplifies really nicely. If it was an open-ended question, a free response, this would be a correct answer. But if it was a multiple choice, you might see your answer in this form, and then that might cause you some distress if you didn't remember what was going on. So 39 is a pretty good one.